Hi everyone, welcome to Practical Electronics. In this tutorial we're going to continue with semiconductors, looking at transistors. In the previous video we did an introduction to semiconductors and we looked at diode circuits. Semiconductors are conductors whose properties may be changed by external factors. They allow or resist the flow of current based on these external factors. Semiconductors allow for intelligence in electronic circuits. Transistors are important examples of semiconductors and active components. In this tutorial, we will look at how transistors work and explore their use cases through a number of circuits. Let's look at the lesson plan. In this lesson, we're going to cover theory. We're going to look at how transistors work, operating states, use cases, transistor equations and values, as well as some transistor circuits. Transistors are active components. They have the ability to amplify and produce a signal bigger than the input signal. Transistors can also act as switches. They can be used to drive large loads from small input signals. While they are used for signal gain, they do not necessarily provide power gain. They are key components of integrated circuits, also known as ICs. The most common type of transistor is known as the bipolar junction transistor. To understand transistors, we need to do a little reminder of how diodes work. Diodes are made up of two semiconductor materials. Bipolar junction transistors have an additional layer of semiconductor material to give characteristics of an amplifier. Transistors are three terminal components. For the BJT, the terminals are called collector, emitter, and base. There are two types of bipolar junction transistors. That's an NPN transistor and a PNP transistor. NPN transistors allow signal current to flow from the base to the emitter. PNP transistors allow signal current to flow from the emitter to the base. The other types of transistors that we have are known as field effect transistors. Field effect transistors are voltage control devices. The output current is determined by the input voltage at the input terminal, known as the gate. The two types of field effect transistors are the junction field effect transistor and the metal oxide semiconductor field effect transistor, also known as a MOSFET. Field effect transistors are also three terminal devices, but the terminals have different names compared to bipolar junction transistors. The collector is known as a drain, the base is known as the gate, and the emitter is known as the source. The symbol for these transistors can be seen on the right side of the screen. Let's look at how transistors work, and we'll use an NPN bipolar junction transistor in this example. The transistor has to be biased in order for it to work. This means that the collector and the emitter should be connected to a point with a potential difference in voltage. A small signal comes in through the base. This function allows sensitive components such as integrated circuits to send signals that can drive larger loads. A smaller current flowing from the base to the emitter allows for the larger amount of current to flow from the collector to the emitter. Now let's look at transistor biasing. For a transistor to work, it has to have a potential difference applied across its collector and emitter. This is known as biasing the transistor. The base is reserved for the input signal. Resistors can be used to control and limit the current flowing across the terminals. Capacitors can be used to filter out DC signals where the transistor is used for an AC signal amplification. Let's look at transistor operating states. Transistors have three operating states. They are known as the cutoff state. This is where the transistor is off and it operates as a switch. There's saturation, where the transistor is fully on, operating as a switch. And there's the active region, where the transistor operates as an amplifier. There are multiple use cases for transistors. Just to name a few, they can be used as digital switches, amplifiers. They are used in power electronics, integrated circuits, as well as for signal processing. Let's look at equations and values for transistors. For currents, transistors have a current gain value known as beta. In datasheets, this value is shown as HFE. The collector current is a product of beta multiplied by the base current. The emitter current is a sum of the base current plus the collector current. When it comes to voltages, there are three voltage points that are important for transistors. There's VCC, which is the biasing voltage, VBE, which is the base emitter voltage, which is typically around 0.6 volts. This is the voltage that is needed for the transistor to turn on. There's VCE, which is the collector emitter voltage. It's important to understand parameters and limits for transistors. So for us to have a good view, we'll look at some datasheets. This datasheet is for a PNP transistor, which shows the schematic and the absolute maximum ratings for this transistor. Scrolling further down, we see thermal ratings for the transistor, as well as electrical characteristics. This is where we can see the current gain demarcated as HFE, and it's shown under different conditions. Similarly, for an NPN transistor, we can have a look at a datasheet for us to understand its parameters. The datasheet will also show maximum ratings, thermal ratings, as well as electrical characteristics for the NPN transistor. Similar to the PNP transistor, we can have a look at the current gain, and we will see the different parameters around it as well. Other limits for the transistor will be contained in the datasheet. Let's look at transistor circuits. First is the common emitter. A common emitter configuration puts the transistor in its active region and allows for it to be used as an amplifier. A small AC signal can be applied to the base of the transistor and it comes out amplified from the collector terminal. This is also known as a Class A amplifier. Next, there's the emitter follower. The emitter follower circuit is called that because the output is taken from the emitter. The output voltage is the input voltage minus 1 diode drop. This circuit does not amplify. But can be used to drive a load from an input source. And then on the screen we have an AC amplifier circuit. When working in the active region, transistors work as amplifiers. Input signals are applied to the base of the transistor. Output signals can be measured at the collector or emitter terminal. In this example, they are being measured from the collector. Capacitors can be used to filter out DC signals. Lastly, for this tutorial, we're going to look at the relay driver circuit. Transistors can be used to drive loads that are larger than their limits. This is done by using transistors to drive relays. Relays are switching devices that have higher ratings than transistors. Diodes can be used in providing protection for the relays as well. And here we see a build of this circuit on a Vero board. These are two relay drivers made using PNP transistors. And now for our wrap up. Transistors are active components. They can be used as switches or amplifiers. The invention of transistors led to the creation of integrated circuits in digital electronics. We're going to make use of transistors in future for some of our main circuits. For more information on transistors, you can have a look at the links on the screen. Thank you, and see you in the rest of the videos.